Okay. All right, if you just hopped on, hi, we're going to get started in 2 or 3 minutes. Give people a little bit of time to get on, and then we'll get going. Said, honey, what you gonna do today? If you guys are on, if you're in my class, you can just use Remind to Talk. If you're not in my class, feel free to use the code right down below me to join Remind so that we can make sure we're all on the same page. Again, if you just popped on, hi, we'll get started in a couple minutes. If you're in my class, you can just use Remind to interact with me. If you're not in my class, there's a Remind code right down below me, and you guys can join that. I won't send you messages. It's just so you guys can interact with me if you'd like to. And we'll get started in a couple minutes. Hi to everybody that just popped on. If you're in my class, you guys can just use regular old Remind to chat with me. If you are not in my class, feel free to use the Remind code right down below me, and you guys can send me messages that way. At any time throughout the night, I want you to send messages. I want you asking questions. The point of this is that you guys get a review. So ask away if there's things that you don't understand or you're not sure about. And we're going to get started in about 1 more minute. We'll give everybody another minute to get on. Again, if you're in my class and you just jumped on, guys, feel free to just use Remind. If you're not in my class, right down below me, there's a Remind code. You can join that Remind. I won't send you messages, but you can send me messages that way. So we're going to get started in a minute. Send questions at any point throughout the night if you have them. And we'll go from there. So we're going to get started in about 30 more seconds. Okay, so we're going to get started. So hi guys, welcome. We're going to be reviewing Unit 5 for Algebra 2 tonight. I can't talk. So at any point during the night, if you have questions, send them to me. That's the goal of this. Right down below me, there is a remind code. If you're not in my class, feel free to join that remind, and you guys can send me questions at any time throughout the night. We're going to go through major topics tonight, but again, if at any point there's something that you have questions about, send them to me, and I am happy to help however I can. So we're going to get started by taking a look at some vocab. So first thing we need to make sure that we know is the vocabulary in this unit, because it's very specific, and it's stuff that's going to come up a lot as we look at the way questions are asked. So polynomial is an expression consisting of one or more terms. Everything will be of the form a x to the k normally, where we're going to have a coefficient and then a whole number power to our variable. Standard form of a polynomial is ascending order by degree from largest exponent to smallest exponent. The degree of a polynomial is the largest exponent of any term when it's in standard form, so it needs to be multiplied out completely. The degree of each term is the sum of degrees of each base. The terms are number, variable, or product of them. Terms are separated by addition or subtraction. And the leading coefficient is the coefficient in front of the term with the highest exponent. So those are the basic overview. Classifying polynomials, again, there are many, many classifications, but these were the ones we focused on. So a degree of 0, where you have no x's, is a constant function. X to the first is linear, squared is quadratic, cubed is cubic, and to the fourth is quartic. And you can keep going up from there, but again, those are sort of the major ones that we talked about. As far as term numbers, 1 term is a monomial, 2 terms, binomial, 3 terms, trinomial. Above 3, normally we just say polynomial. So those are our basic vocab terms. So as we work throughout the night, those are the things that I'm going to be looking at as, do we have this stuff down? Okay. So we're going to start with polynomial division as sort of the first major new thing that we did in this unit. Addition, subtraction, multiplication is pretty old, but division is something that was new. 2 things to be mindful of when you're doing division. Number 1, are you putting zeros in for your missing term? Number 2, are you subtracting, right? Divide, multiply, subtract, bring down. So make sure that you're doing that. So for this first one, and we're going to do a couple, we've got f of x equals 3x squared plus 7x minus 20. G of x is x minus 2. State the quotient and remainder of f over g. Don't let that scare you. That in notation, f over g is saying f divided by g. So what this is really saying is take f, which is this, and divide it by g, right? That's all that's saying. So when I do this, I'm going to do, does McDonald's serve burgers? Divide, multiply, subtract, bring down. And we're going to go through this. So I'm going to start by looking at the first terms, right? Just those first terms. And I'd say to myself, okay, what do I multiply x by to get 3x squared? Well, I would need to multiply by 3, and I would need another x. So that's divide and multiply. Or that's divide. Now I need to multiply. 3x times x is 3x squared. 3x times negative 2 is negative 6x. Now, you can either put parentheses around that and write your subtraction, or what I like to do is just know that I'm subtracting this, I'm subtracting a negative, so that becomes addition, and that helps me sort of combine my like terms there. So the first 2 terms will cancel out. These are going to be 13x, and then you can bring down your minus 20, so that's subtract and bring down. Now, repeat this. So we're going to do x and 13x. So that's plus 13. And then multiply. So 13x. And then 13 times negative 2 is negative 26. And subtract this. Subtract a negative makes it plus. So that leaves me 6 left over. So my remainder is going to be 6 over x minus 2. The remainder being 6 there. So just make sure you're rewriting it with your remainder over your divisor out here. Okay, we're going to do one more, and this one is a little bit different, not only because of the way it's written, but because there is a missing term. So I am missing the x squared term here. So I've got the x cubed, so x cubed, missing the x squared term, so I'm going to fill that in. then I want to have plus x and minus 1. And you're going to know if you tried to fill this in and it didn't, or if you forgot to fill it in, because you're going to notice as you're dividing things don't quite line up. So you can always go back and add it in later if you forgot, but make sure you're looking for that missing term. So I'm going to look at, again, my leading coefficients in each one. So x times what would give me x cubed? That would be x squared. And now I'm going to multiply. So x squared times x is x cubed. X squared times 2 is 2x squared. And I'm subtracting each of those. So this is going to be negative 2x squared because it's 0 minus 2. And then bring down. So plus x minus 1. Now the cycle continues. So look at your x and look at your leading coefficient there. That's going to be negative 2x. Multiply, so that gives me negative 2x squared minus 4x. And then you're subtracting those, so they both switch signs to multiplication. Now that would give me 5x here, and then minus 1. Now here I would have plus 5, because we would need to multiply by 5 to get 5x. Now multiply, so 5x and 10. I'm subtracting each of those, so this gives me a remainder of negative 11. So this would be plus negative 11 over x plus 2. So just because you're missing a term in your original polynomial doesn't mean it'll be missing in your quotient, and just make sure you're careful and you fill that in. So that's all I have for polynomial division. We're going to use it throughout the night. But generally, this was something that at least my classes were pretty strong at, so I'm not going to spend a ton of time on it. But if you have questions, send them along, okay? All right, the factor theorem. And I tried to simplify this down from what was in the notes a little bit, get down to the nitty-gritty parts of this. Here's what the factor theorem says. It says, if x minus a is a factor, then x equals a is a 0. And if x equals a is a 0, then x minus a is a factor. So this is going to help me move between factors and zeros. What's up, Mr. G?
Just saying hi.
Just saying hi. All right, you weren't even in it. Do you want to?
Hi. Is this Algebra 2?
Yeah, it's Algebra 2.
Hi, Algebra 2.
Okay. The room's a mess because we're packing. Okay, so if x minus a is a factor, x equals a is a 0. If x equals a is a factor, x minus a, or x equals a is a 0, x minus a is a factor. So we're going to start by looking at it this way, which is writing a polynomial in standard form when I give you the zeros. So what this theorem says is that if I know a 0, then the factor will just be x minus that 0. So if I start with this one, these are my 3 zeros, right? So 3 zeros should tell me that I have 3 factors. And then I'm going to have like x minus 2, x minus 5, x minus 1. Notice I'm changing the sign on each of those. I'm making it x minus the 0. Now it says write a function, so you should have either y equals or f of x equals. And if it said in factored form, you'd be done there. But it said standard form. So standard form, we need to keep going. We need to multiply that out. So when you multiply 3 things together, think if I just multiplied like 1 times 2 times 3. First thing you would do is multiply 1 times 2. That's just 2. And then you'd multiply those 2 together. So we're going to do the same thing here. So multiplying these 2 together, I'm going to get x squared. Now that's minus 5x minus 2x. So that's minus 7x plus 10 times x minus 1. And now I can multiply those together, and you can go box method, you can go distribution, but I am going to do this using just distributive property. So I'm going to start by multiplying the x out to each of these. So x cubed minus 7x squared plus 10x. And then I'm going to multiply the negative 1 out to each of those. So minus x squared plus 7x minus 10. And combining my like terms, I've got x cubed minus 8x squared plus 17x minus 10. And you should still have your f of x equals there. So again, standard form, make sure it's multiplied out. Now let's look at sort of the extension of that, which gave people the heebie-jeebies a little bit, but that's okay, we can handle this. So same idea, except my zeros might be imaginary now. So same thing, let's say y equals, because it's a function. Now, negative 2 will be x plus 2, and then this will be x minus 5i, and x plus 5i. And if it said leave in factored form, you'd be done. But again, standard form we want to multiply out. What I always tell my classes is when you are dealing with i's, multiply the two with i's and them together first, because i's have a way of canceling each other out and becoming real numbers, because I times I is I squared, and that is a real number. So I'm going to leave the x plus 2 for now. I'm going to multiply these two together, and I'm going to get x squared minus 5ix plus 5ix. Those middle terms cancel each other out. And then minus 25i squared. Now remember that I squared is -1, and if you forgot that, put it in your calculator. So this is really -25 times -1. And so this is going to give you x squared plus 25. So I'm really winding up with something that has all real coefficients there. So now multiplying these two together, I'm going to have x cubed plus 2x squared plus 25x plus 50. And that would be that multiplied out into standard form. Okay, send questions as you have them, but now we're going to start looking the other direction. So now instead of giving you the zeros and asking for the factors, I'm giving you the factors and asking for the zeros. So here's the deal with this. So each one of these is a factor. And to figure out the zeros, I can say just set each part of that equal to 0, right? Now, I don't need to worry about this exponent here because that factor will equal 0 when the base of the exponent is 0. So that's really what I'm going to do. Now, this one's already solved for x. This one I'm going to move over, solve that for x. This one I'm going to move over and solve that for x. So I've got 3 non-real zeros roots there. All right, next one, I want to find this. Now, this one's not in factored form. So what that tells me is I need to get it into factored form. So 4 terms, first thing I'm always going to look for here is a greatest common factor. These all have an x in them. So I'm going to take out an x, which leaves me with x cubed plus 5x squared plus 3x plus 15. Now, 4 terms still in there. Whenever I have 4 terms, I'm going to factor by grouping. So grouping my first 2, GCF is x squared, and that leaves me with x plus 5. Excuse me. Grouping my second 2, I can take out a positive 3, and that leaves me with x plus 5. And so that x is still on the outside. So this leaves me with x plus 5, and x squared plus 3. So I've got 3 factors here, just like I did on my last one. Now, let's set these each equal to 0. So x equals 0, x plus 5 equals 0, x squared plus 3 equals 0. And let's solve these. So this one's done, already equal to x. This one, x equals -5. And then this one, I'm going to have to solve it. So x squared equals -3. And I'm going to square root both sides. So x should be plus or minus. Now square root of 3 is square root of -1 times square root of 3. So that should be I radical 3. So don't forget the plus or minus. And that actually gives you 2 solutions there. So when I look at the zeros of this polynomial, I actually have 4 of them, right? 1, 2, 3, 4. 2 are real, 2 are non-real, or 2 are imaginary. All right, let's do one little challenge and then we'll get back. This is something that's a little more difficult, not the typical way they'd ask a question, but a good challenge for us to think about. So this says divide this by x plus 4 and find all zeros of the polynomial. So let's start with what they tell us to do. Even if I have no idea what else to do, I could start with what they tell me to do, which is to divide. So x cubed plus 3x squared minus 10x minus 24 divided by x plus 4. So let's actually do this division. So I'm going to look at x goes into x cubed. That would be like x squared times. So that gives me x cubed and 4x squared. I'm going to subtract each of those. So this is -x squared, bring down minus 10x, minus 24. So that's what I'm starting with. Sorry, guys. I have a cold. It's not good. All right. Now, let's keep going here. So x and negative x squared would be negative x. So multiply that. That's negative x squared minus 4x. And I'm subtracting, so change both of those signs. So that would give me negative 6x minus 24. Now, x and negative 6x, that would be negative 6. And this gives me negative 6x minus 24. You're subtracting, so change both signs, so that gives me 0. So I know here that x plus 4 is a factor, right? It goes in evenly. Now, if x plus 4 is a factor, and I'm looking for the zeros, I can already tell you that x equals negative 4 is a 0, right? If x plus 4 is a factor, x equals negative 4 is a 0. So I can eliminate any answer choices that don't have negative 4. So it's definitely not letter A. Now, how would I figure out the remaining zeros? You could look at a graph. There's a bunch of different things you could do. But here's what I would say. When we divided, we got this left over, right? So I can actually take that and say, okay, that's what's left over when I divided. Could I break that up more? And this is pretty easily factorable. This factors to be x minus 3, x plus 2. And so the zeros of that would be 3 and negative 2. So I know that this is a 0. And then I took what was left over and I factored that, and that gave me that 0, right? So this should be B, because I've shown that these factors were x plus 4, x minus 3, and x plus 2. Now again, that's a little more challenging, but that gave me my 3 zeros. Okay, send questions if you have them, guys. Let's talk remainder theorem. And this is the theorem that makes your life easier, so you don't have to divide on every single problem you get, okay? I don't always want to have to divide if I don't have to. So here's what the remainder theorem says if I boil it down. It says the remainder when p of x is divided by x minus a is equal to p of a, okay? So that told me that I can take the 0 of my divisor, plug it into my original function, the thing I'm dividing, and that will give me the same thing as the remainder. So let's look at this. Which of these is a factor of x to the 4th minus 4x squared minus 4x plus 8? Now, could you sit there and do division 4 times? Have fun. You go do that. You'll get it right, but it will take you a long time. So here's what I'm going to do. I'm going to use the remainder theorem. If it's a factor, remember that I'm looking for the remainder to equal 0, right? So if it's a factor, the remainder should equal 0. So I'm going to use the remainder theorem and see which one spits me out 0 as my remainder. Now, these are my 4 factors, so I'm going to figure out what the associated 0 is for each of them. So for each of these factors, the associated 0 will be the opposite. So I've got 4 possible zeros here. Now I'm going to plug those into my original function and say, okay, which one of these actually is the 0? So let's look at it. If I do it for 1, that would be 2 to the 4th minus 4 times 2 squared minus 4 times 2 plus 8. So this is going to give me 2 to the 4th is 16 minus 4 times 4, which is 16, minus 8 plus 8. And guess what? That gives me 0. So I'm going to guess that it's 1, but let's try a couple others just to make sure. So here, if I try 2, I've got negative 2 to the 4th minus 4 times negative 2 squared minus 4 times negative 2 plus 8. So this would give me 16 minus 16, same thing. But now it's plus 8, and that gives me 16. So I know it's not 2. And you could keep checking for 3 and 4. But again, once you see that the output is 0 when you plug in, you know that the remainder, if you divided, would be 0. Okay, let's look at one more of these, and then we will move on. So The graph of p of x is shown. This is p of x that we're looking at. What is the remainder when p of x is divided by x plus 4? And a lot of people will look at this and be like, yeah, not a clue. Don't know. Just going to guess. Maybe it's the value of the 0. I don't know. So here's what I would say on this. If I'm looking for the remainder, right? If I'm looking for the remainder, let's start with figuring out, well, what x value are we even worrying about, right? So here, I would say if this is the factor I'm worrying about, the 0 that I care about, the related 0, is -4, the thing that would make that equal 0. So I'm looking at when x is -4. Now what the remainder theorem says is the remainder should be the same as p of -4. So I don't need to divide. The remainder would be the same as p of -4. So let's do that. So let's look at it. At -4, that point is -4, 0. So if that's x, that's, remember, p of x, because that's your y value. So your output is 0, which means your remainder is 0. Now, I saw some people trying to do this problem in my class today, and they were trying to rewrite out the equation, right? So find these zeros, write an equation, and then do the division. That would work, but it's a lot more work than if you understand this theorem and know that, okay, I'm looking at x plus 4, so my x value is -4, and the remainder should be equal to the value of the function there. Okay, send questions if you have them. We've got about 3 more quick topics, so we are cruising through these. All right, so this next one is about end behavior, and we did a lot of dancing of this in class, right? But this is something you got to know. I know you can look at your calculators. I know that. Use them. They're resources. But you should also understand the idea here. And remember in my class, we talked about the idea of end behavior models. So we talked about the fact that one of these is going to behave more like a parabola, and one of them is going to behave more like a line, right? So if the degree is even, it's going to behave on its ends like a parabola. I don't know what it does in the middle, but on the ends at least, it will either be up, up, or down, down. If it's odd, then it will be opposites, right? So it'll either be down, up, or up, down. So those are what I'm looking at there. Those are my rules. If you need to study these, go for it. But remember, if you're ever stuck, you can look at your calculator. So let's look at these. Describe the end behavior for each of the following functions. Now, I'm going to do little sketches for these, but I will do a couple with notation just to make sure we're familiar with that. So let's look at this first one. So look at your degree. Your degree is your highest exponent, so your degree is odd. In my mind, I'm already going, okay, this will behave more like a line because lines have an odd degree. Now, this has a positive leading coefficient because the number out here is just a +1. So this is going to have the same end behavior as a line with a positive slope. Now, how would I write that? Well, I would say on the right, which is as x goes to infinity, the graph goes up, which is f of x goes to infinity. And on the left, which is as x goes to -infinity, the graph goes down, which would be f of x goes to -infinity. All right, let's look at another one. Look at 12. So on this one, look at your degree. There's your degree, right? That's a 4. So I already know that's even. This is going to behave more like a parabola than a line. Now, is it a happy parabola or is it a sad parabola? Well, this has a leading coefficient of 1, +1. So this is going to have the same end behavior as a positive parabola. So in notation, I would say, okay, as x goes to the right, f of x goes up. And as x goes to the left, f of x goes down. Oh, I'm sorry, it goes up. It's up, up on both sides. All right, next one. So if I look at this one, I see, okay, degree, even. That's going to behave more like a parabola. This actually is a parabola. And my leading coefficient is negative. So that is going to be a negative parabola. It's going to be down, down. Now, this one, as x goes to the right, f of x goes down. And as x goes to the left, f of x goes down. Okay, let's do one more. Let's look at number 19. So f of x equals negative 2x cubed plus 5x squared. Degree, look for your biggest exponent. That is 3, so it's odd. That to me says this will behave more like a line than a parabola. And the leading coefficient is negative, so this is going to behave like a line with a negative slope on the ends. So, as x goes to the right, the function goes down. And as x goes to the left, the function goes up. All right, we're going to do one last one, and then we're going to put it together and draw some graphs. So, which of these graphs has the following characteristic? 3 real zeros. So what that means is that it has 3 x-intercepts. Now, they might not all be unique. There may be multiplicities, but it shouldn't have more than 3. So not more than 3. So let's go through and just cross out ones we know can't work. This one has 3 x-intercepts. That's got it. This one looks like it only has 3, but that has a multiplicity of 2. So it can't be that one because that has a bunch more real zeros. Now, this one has 3, and this one has 4. So it can't be that. Now, let's look at this one. This says as x goes to the left, f of x goes down, and as x goes to the right, f of x goes up. So this should be going down on the left, up on the right. So let's look at that. Down on the left, up on the right, that is this graph. So look at your end behavior. Really, you didn't even need that so much. You could have just looked at the end behavior on this one. All right, second to last, we're going to talk about graphs and symmetry. So I want you to take a look at this for a second. These are some of our multiplicity rules, and I need to plug my laptop in before it dies. So look at that for 30 seconds while I plug this baby in. Okay, that was not 30 seconds, but so big thing with multiplicities is what you need to remember is that if you have an odd multiplicity, it will cross. If you have an even multiplicity, it will be tangent. It will hit but not cross. So this one has a multiplicity of 1. So this would be x minus a. Here a is 0 to the first, right? So it crosses. Here, this would be x minus my 0 there is 0 squared because it has a multiplicity of 2. Notice it's tangent, touches but doesn't cross. And this one crosses but flattens out a bunch. So that would have a multiplicity of 3. I'm really focused on the touch or cross thing. The 1, 3, 5, 7. Does it flatten? Does it flatten a lot? Like all of that stuff you could look at your calculator to check. The big thing I want you guys to distinguish between is the idea of a graph versus the idea of a sketch. If I just give you like a coordinate plane and I say sketch it, I want to know where the zeros are. I want to know that your end behavior is right. But if I give you a graph and I say graph, then you can use your graphing calculator and get a bunch of points. Graph should be more precise than sketch. So that's one thing to keep in mind. So we are going to sketch these. We're going to sketch them. I'm not so worried about the actual y values. I'm worried about the shape. So let's look at this first one. So I'm going to start with my zeros. Let's figure out where those zeros are. So this would have a 0 at -2, at 1, and at 4. So at -2, at 1, and at 2, 3, 4. There's my zeros. Now, let's think about, let's think about our end behavior. So this doesn't have an x with it, so that doesn't have any degree that we need to worry about. That's a degree 0 term. This is x to the first. This is x to the first. This is x to the first. So the degree here is 3, right? My leading coefficient is 3. That's positive. So odd leading coefficient, positive leading coefficient, or I'm sorry, odd degree, positive leading coefficient. This should behave more like a line, right? So my end behavior will be up on this side and down on this side. Now, does it touch or cross at each of these? So each of these have an exponent of 1, right? So this will be cross, cross, cross. They will each cross because there's no multiplicities that are even. So I'm just going to connect these. I'm going to start at this end behavior down here. I'm going to cross there, cross there, cross there, and connect it to that. So it's a sketch. Can you check it on your calculator? Go for it. But you should be able to tell me multiplicities and all of that stuff without it. All right, let's look at this next one. So let's start with end behavior because this one's not in factored form. So this degree is 4. And my leading coefficient is 1 because there's a 1 out front. So this is positive and even. So this is going to behave most like a parabola. Now, let's do a little bit of factoring to investigate what it will do because I know the end behavior will look like that. So we just need to figure out what happens in the middle. So to get the zeros, I'm going to factor this. I'm going to take out an x squared. That leaves me with x squared minus 4. And that factors further to be x squared, x minus 2, x plus 2. Right? So that's factored completely. So my zeros here are at 0, 2, and negative 2. So 0, 2, and negative 2. Now, multiplicities. This one has a multiplicity of 2 because of that exponent. The other two have a multiplicity of 1. So what that means is anywhere you have an even multiplicity, here it's going to touch but not cross. And here it will cross, here it will cross. So here's what this means. At 0, it should touch but not cross. Everywhere else, it should cross. So it's going to come down and cross. And then it's going to touch at 0 but not cross. And then cross here and go up to my end behavior. Now, you can look at it on your graph. Make sure it's about right. Okay, let's look at the last two with this. So this one, let's look at our zeros. Or actually, let's skip that one for right now. Let's look at this one. So let's start with our end behavior. Leading coefficient and degree. So leading coefficient here, there's just a 1 out front. It's not positive or negative, so that's just a 1. Degree, you've got x squared there, and then x to the first here, so the degree is 3. So positive and odd, this should behave more like a line. Now, let's think about our zeros. So our zeros here are at x equals 2 and at x equals negative 3. Those are my zeros, right? And let's think about our multiplicities. This one has an exponent of 2, so a multiplicity of 2. This one has an exponent of 1, so a multiplicity of 1. So let's sketch. This is going to go down to the left, up to the right. It's going to have x-intercepts at negative 3 and at positive 2. And let's think about touch versus cross. At 2, it should touch but not cross. At negative 3, it should cross because of your multiplicities. So if I follow my end behavior, this is going to go up and cross, come down and not cross, and then go back up. And that is what that graph should look like. So you can check yourself on your calculator, but you should be able to do end behavior, zeros, and multiplicities from the formula. Okay, last thing, and then we're done for this test, is symmetry. So talking about whether a function is even, odd, or neither. So if something is symmetric about the y-axis, it will be even. Okay, even functions are symmetric about the y-axis. F of negative x and f of positive x will be the same. So that's an even function. Odd will be symmetric around the origin. And that means you could rotate it 180 degrees and it should map onto itself. Ooh, geoterm. I like that. Now, let's see if this actually works. Ready? If I take this and then I actually rotate it 180. So you guys could do this, like, you know, rotate your paper. I can do it through the technology magic here. But if I actually rotate it 180, look, it maps right back onto itself. So don't be afraid to, like, be that person with your paper, like, spinning. It's totally fine. That's me. So it's good. All right, let's do a couple of these. So this first one, even, odd, or neither. Definitely not even, right? It's not symmetric over the y-axis. Let's see if it's odd. So if I actually like take this and spin it upside down, would it be the same? Some crafty spinning here. It would. It maps right back onto itself. The other way you can look at it is look at it and say, okay, that point is 1, 3. That point is -1, -3. That's just spun 180 from each other, right? You could even see if you looked at this like a line that's spun 180 degrees around. So this would be odd. All right, number 2, even, odd, or neither. Definitely not even, right? Not symmetric over the y-axis. Now, is it odd? If you spun this upside down, would it be the same? I'm already going to say no because look at where this crosses. It crosses at 0, 5. If you spin it upside down, it's going to cross at 0, -5. That is rotated 180 degrees, right? So I'm already going to say that this is neither because if you rotate it, it's not the same. All right, next one, even, odd, or neither. Even kind of jumps out at you. This is symmetric over the y-axis. That's your line of symmetry, if I could draw it. And so since it's symmetric over that, it's even. And then the last one, even, odd, or neither. Flip your paper upside down, see if it's odd. It's definitely not even. Or look at your points. That's like 1/2, 1.5, -1/2, -1.5. That's like 1.5, -3.5. That's like -1.5, +3.5. So this is odd. They're exactly rotated 180 from each other. So this is an odd function. So with your explanations for even and odd, make sure you're saying it's symmetric over the y-axis, or it's symmetric about the origin, or it's rotated 180 degrees. Most of the points I wind up taking off for this are people who just say it's symmetric or just say it rotated. So you have to be a little bit more specific than that. And that's really what I have for your test, guys. If you can do this stuff, I think you're going to be plenty prepared for your test. Remember that on your unit overview, on your stamp sheet, you guys have all of your learning targets for the unit, so you can go through and look at that. You have the review sheet. The review sheet key is on my teacher site. And that's all I had prepared for you guys. So, what questions can I answer? I'm going to hang out for about 3 minutes, and then we're going to move on with our lives. I'm going to go. Probably go to sleep. Don't be afraid to ask a question. Other people are waiting. No one has logged off yet because they're waiting to see if someone else will ask a question. So if you have a question, this would be a great time to ask about it. These are your moments, guys. Precious moments slipping away when you could be asking math questions. Sorry. This whole not having a snow day thing is really getting to my sleep habits, guys. I needed that snow day. All right, I'm giving you like 30 more seconds, guys. Only one person is logged off because everyone's waiting to see if someone will ask a question. Another division problem where you have to add the 0 in. Yes, let's do it. Okay, so you're going to have to add the 0 in anytime you have a missing factor, right? So if I gave you a problem that was something like x to the let's do x to the third plus x squared minus 3 all over, we could get really crazy here, x squared plus 1. So we've got this, right? So I've got a bunch of missing terms in this one. And if you want to really get into missing terms, this would be where I'd start. So in my numerator, that's going to be the part inside the division box. I'm missing an x to the first. So I'm going to copy x cubed and x squared. And I'm going to add in a 0x to the first. Because I need that to go cubed, second, first, 0, right? Now for this denominator part, I'm missing another factor. I'm missing the 0x to the first. So you can do this without adding in the 0 on the outside. A lot of people do, but I'm going to add in the 0 on the outside. So this is going to be x squared plus 0x plus 1. You don't have to do that as long as you line everything up, but that's another place where you might add in a 0. So we're going to look at our first terms. So x squared times what would give you x cubed? That would be x. And then I'm going to multiply. So x times x squared would be x cubed. X times 0x is just 0x squared, right? And then x times 1 is x, 1x. And I'm subtracting each of those. So this will cancel out and give me 0. This will cancel out and give me 0. And so this just leaves me with negative x. And bring down your minus 3. Now, make x squared go into negative x. That's not a thing. So that would be a point on this one in particular where I would be done. There's nothing else I can do. That's my remainder. So it would be plus negative x minus 3 over x squared plus 1. So if you're missing a factor on the inside or the outside, or a term, I'm sorry, not a factor, on the inside or the outside, you can add it in there. All right, this is it. Last shot. If you have other questions. Okay, guys, send me other questions on Remind if you have them. Good luck. You'll do great. And I hope everybody has an awesome break. See ya.